geometric probability. It's just like probability, except for we're going to use geometry. Any kind of probability is going to be favorable over total. I'm not going to waste a bunch of ink, I'm just going to label things. If we split this up, it's already in two pieces. There's two parts, that's the total, and blue makes up one of those parts. The probability of getting blue is 1 out of 2. If I wanted to be silly and say, what's the probability of getting something white, I could ask that, and it's going to be 0. These probability questions are going to be like if we were to take this, if it's a piece of paper, we're going to take it and split it up into a bunch of little pieces, and then we were to randomly choose. So sometimes you like to think of it as if we're going to throw a dart, what's the chances, except for darts are not just random, and this is going to be very random. It's what's the chance of randomly selecting any of these pieces. We're going to use this image next. We're going to say what's the probability of randomly choosing red. So notice there's 4 different pieces. So we're going to do favorable over total, and the red is the favorable, and there's 1 red box. So it'll be 1 over the 4 total. The probability of getting red is 1 out of 4. For yellow, there's 2 different yellow boxes. So it's going to be 2 out of 4. Be sure to reduce. It's really 1 half. And then the probability of white is going to be 1 out of 4. Again. Here we want favorable over total. If we're going to calculate the probability of getting white, we need to have the total white area, and we need to have the total area for the denominator. So, this side over here, the vertical side is 8 units long, and the horizontal side is 8 units long. I did not do that on purpose. Which means the total is 64. Because it's area, so we did length times width. The white is going to be 1 times 3. And then we're going to move to this piece, which is 2 times 3. And then we have this piece over here, which is 2 times 5. So we have the total area, and then we have each white piece. So we're going to add together which gives us that for the probability of randomly choosing white on this. The probability of getting pink. And then I don't have to show the work for the total because I've already done it. And then the pink is just this 2 by 5 box over here. That's the probability of randomly choosing pink. So here we're going to have concentric circles. The inside circle has this radius of 5, and then that's the red circle. Then the next ring is purple. Well, that circle is going to have a radius of 7, because you do the 5 plus 2 to get 7. And then the outside ring, which is green, that circle has a radius of 9, because you go from the center to the end, and you have 5, 2, and 2. So we're still going to do the probability, and it's going to be favorable over total. And let's calculate the probability of getting something red. Remember that the area of a circle is pi times radius squared. So the area of the red circle is pi times 5 squared. Here, the pi's will cancel. So that's the probability of finding red. When we find anything else besides the inside one, you have to be careful because we're going to do the area of the purple. Well, that circle has a radius of 7, but not all of that is purple. So then we're going to subtract the inside, the red circle, and it has a radius of 5. It's still got the total of that 9 squared. So the probability of finding something, of randomly choosing a color and getting purple is going to be 8 over 27. The green ring has that radius of 9. We do need to subtract everything that's inside of that. So that's 7. And then it's over that 9 squared with the pi. The pi's will cancel, and you're going to get 32 over 81. So the probability of reaching in and choosing something at random and getting